Anong magre-report?
Oo, sir.
Si
Oo,
si
sir.
Lance? Lance, ikaw?
Hindi po, mamaya po sila, sir.
Sinong una?
Tesoro.
Okey. Tesoro Jeremiah, sige.
Sir. Okay. Good evening, sir,
Good evening.
classmates. We are the fifth presenter, here to discuss the basics in the field of soda/manufacturing. Next slide, please. Here's the outline of the presentation. Next slide, please. So a little bit of background of soda/cola. First of all, we asked the question, what is a soda? How do we classify a soda per se? Well, first of all, a bit of a fun fact. Sodas are slightly different from soft drinks. And by that, I mean all sodas are soft drinks, but not all soft drinks are sodas. The term soft drink was originated to distinguish the flavored drinks from hard liquor. The term soft is used in contrast to hard, which is alcoholic drinks. Soft drinks were recommended as a substitute in the effort to change the hard drinking habits of early Americans. You see, they enjoy hard liquor so much that it causes health problems, so they created a variation to a lighter beverage, hence the soft drinks. In simple terms, soda or carbonated water is a mixture of water and carbon dioxide. You might ask if the chemical composition of structure of a water is made up of just hydrogen and oxygen, then how does a carbon dioxide get in? It doesn't appear just like that. Companies add carbon dioxides inside the water at a pressure of 1,200 pounds per square inch. When the bottle is shaken well due to this pressure, the gas gets settled inside the water molecules and it fizzes. By shaking, gas tries to find a way to escape, and that is why we hear the fizz sound and the volume of the drink racing above the bottle. Soft drinks include sodas, colas, pop, iced tea, sweet tea, tonic, fruit punch, sweetened powered drinks, lemonade, and other aids, as well as sports and energy drinks. So it's not just about um, soft. Sodas are not just about soft drinks. Soft drinks cover a wide variety of other beverages. Next. So, for a brief history of sodas, the first marketed soft drinks appeared in the 17th century as a mixture of water and lemon juice sweetened with honey. During the ancient period, there was a belief that water from springs was carbonated water, and by drinking water, one can cure the sickness in our body. This is how scientists began to work to introduce carbonated water as an alternative mineral water. Already, the flavored soda waters were hailed as brain tonics for curing headaches, hangovers, and nervous afflictions. The market expanded in the 1830s when soda water was first sold in glass bottles. Filling and capping the gaseous liquid in containers were a difficult process until 1850 when a manual filling and corking machine was successfully designed. The term soda pop originated in the 1860s from the popping sounds of escaping gas as a soda bottle was opened. In the early 1880s, pharmacists experienced with powerful stimulants to add soda water, including cola nuts and coca leaves. In 1886, an Atlanta pharmacist, John Pemberton, did combine cola coca, thus creating what would become the world's most famous drink, Coca-Cola. And a few years later, another pharmacist, Caleb Bradham, created Pepsi Cola in North Carolina, which is derived from the word pepsin, an acid that aids in digestion. Until the 1890s, soft drinks were pronounced manually, from blowing bottles individually to filling and packaging. During the following 2 decades, machinery greatly increased the productivity of soft drink plants. Probably the most important development in bottling technology occurred with the invention of the crown cap in 1892, which successfully contained the carbon dioxide glass bottles. The crown cap design endured for 70 years. And in the 1950s up to the present, aluminum beverage cans were introduced, equipped with convenient pull ring tabs and later with stay-on tabs. Lightweight and break-resistant plastic bottles came into use in the 1970s, though 1991 that the soft drink industry used plastic polyethylene turf plate, which was discussed earlier in the beer manufacturing on a wide scale. So that's about it for the history. Next slide, please, and for the next presenter. Raw materials. Thank you, sir.
Thank you, thank you. Very good.
Okay, so what we have here is the raw materials. First, carbonated water. Excuse me. Rinig po ako.
Dinig naman, oo.
Okay, so carbonated water constitutes up to 94% of a soft drink. So carbon dioxide adds that special sparkle and bite to the beverage and also acts as a mild preservative. So itong carbon dioxide, ito yung ginagamit suitable for soft drinks because it's non-toxic and it's relatively inexpensive and easy to liquefy. The second main ingredient is sugar, which makes up to 7 to 12% of a soft drink. Used in either dry or liquid form, the sugar adds sweetness and body to the beverage, enhancing the mouthfeel, an important component for consumer enjoyment of a soft drink. Sugar also balances the flavors and acids. Next one is acids. So the overall flavor of a soft drink depends on an intricate balance of sweetness, tartness, and acidity. Uh, Acids adds a sharpness to the background taste and enhance the thirst quenching experience by stimulating saliva flow. Yung common na acid sa mga soft drinks is citric acid. Siya yung lemony flavor. Nire-reduce din nito yung pH levels para sa mga ano. At saka nakaka-add sa pag-preserve ng beverages. Meron din yung ano, emulsion. Emulsion. May isa pong tawag doon pero emulsion na lang po. Ito yung nag-a-add din sa soft drinks, the flavor para sa cloudiness and the color for the beverage. Aside from that, dinadagdag din yung antioxidants such as BHA and ascorbic acid para ma-maintain yung color and flavor. Yun lang po for raw materials.
Okay. Thank you.
So, ayan, manufacturing process ng soda or cola. Meron tayong 5 processes. May process dito. 3 muna din. Sa next slide yung 2. So, first, clarifying the water. Kita dito na coagulation tank. So, yung coagulation process kasi, ito yung pagdagdag ng iron or aluminum salt such as aluminum sulfate or tinatawag din itong alum sa sa water natin, yung raw water, para magkaroon ng bond between the coagulant tapos yung impurities ng water. Okay, so pagtapos mag-bond nun, magkakaroon ng chemical reaction, then makakabuo ng pinaka-flux. Tawag doon na flux. Or pag sa wastewater treatment facility, yung sinasabing sludge. Then magsususpend yun sa ilalim by means of gravity. So, mafe-filter out yung first impurities, parang ganun. First stage ng filtering. Then next, after nun, pupunta siya sa filtering, sterilizing, and dechlorinating the water. So, dadaan siya sa ito, parang sand filter 'to, ayan. Kasi yung sand ano siya, fine particles. So, once the water after being treated with coagulant, dumaan siya dito sa sand filter, makaka-remove pa tayo ng other impurities which is, larger than the sand. So next, after niya pumunta sa sand, storage tank where free chlorine is added. So, yung chlorination, important disinfectant siya. Tapos siya yung process ng pag-add ng chlorine to drinking water para ma-remove yung, say, other impurities like parasites, bacteria, or virus. So, yun. Pagtapos nyon, pupunta na siya sa carbon filter. Yung carbon filter, ano siya, type ng filter na nagre-remove ng certain chemicals, particularly organic chemicals from water. Pwede rin siyang gamitin para ma-remove yung odor or taste sa water since ano nga siya, water treatment. So may hindi natin maiwasan na may mga ganong instances. So next, ano to? Mixing ingredients. So meron ditong sterilized water, ito yung galing sa carbon filter. Tapos syrup mixture. Ito na yung ano natin, sugar na ginawang syrup, tapos imimix siya sa mixing chamber. Okay. Ay, hindi ko pala nabanggit yung dechlorination. So, ibig sabihin pala ng ano, sa carbon filter natin na dechlorination, ito yung pagmi-minimize ng effect ng ano, ng potentially toxic disinfection byproducts, which is yung chlorine natin, may potentially toxic ano siya, byproducts. So, ano, yung dechlorination, na-achieve siya by adding sulfur dioxide or sulfide salts. So, yan. So, next slide. Carbon. Yan. So, meron tayong carbonating. So, what is the point of carbonated drinks or carbonating the drink? Para magkaroon ng acidic bite, tulad nga nasabi ni Jalen kanina, or cooling sensation with every sip. So, yung bubbles, nakikerry siya ng aroma ng beverage to engage our sense of smell, as well as taste. So, ba't ba nagbabubble pag inopen natin yung soft drinks? Kung mapapansin nyo, pag bibili kayo ng soft drinks, once inopen yung pinaka-cup niya, is sizzle or umakit yung parang bula-bula niya. Kasi, yung pressure sa loob ng bottle or can or aluminum can is controlled. Ibig sabihin, pressurized. Mas yung pressure niya kaysa sa atmospheric pressure. So, pag
Kasi,
bottle, na-expose yung liquid, which is yung pinaka-soft drink mo, sa atmospheric pressure. So, yung pressure ng carbonated beverage, syempre, bababa siya kasi marirelease siya sa pinaka-container. Then, yung carbon dioxide na dissolve in liquid, magiging gas. Tapos, mag-escape siya sa liquid. Kaya kung mapapansin nyo, yung bula nun, laging pataas. Palabas siya ng bottle. Or minsan, di ba, pag inalog natin, lumalabas pa siya dun. Umaapaw, ganun. So, last stage ng manufacturing, filling and packaging. So dito, ang ginagawa kasi dito yung pinaka-mixture natin kanina na syrup tsaka water, dito na pinapour sa carbonated natin, parang bottle na may water, ganun. Tapos, yung gamit dito, pwedeng bottle or pag-can, aluminum can. So yun, after carbonation is added to the mixture, it's transferred packaging area where it is quickly sealed and labeled. So di lang dyan natatapos yung pinaka product natin kasi dadaan pa siya sa quality control. So yun yung di-discuss ni Mr. LD. Thank you, sir.
Ako pa rin po yung sa control.
Ay, sorry, si Jalen pala.
Quality control. So, the National Soft Drink Association and other agencies sets standard for regulating the quality of sugar and other ingredients. So dito sa quality control, alam naman natin na stricto sila dito kasi dito sinusuri ng mabuti yung mga product or ingredients. Katulad na lang ng if may low quality sugar, so possible na mag-spoil siya agad. So para ma-prevent yon, yung sugar dapat carefully handled in dry sanitized environments. So it is crucial for soft drink manufacturers to inspect raw materials before they are mixed with other ingredients because preservatives may not kill all bacteria. Kagaya nga ng mga kanina sa mga acids, hindi rin makikil ng bacteria. Possible, meron pa rin. So, all tanks, pumps, and containers are thoroughly sterilized and continuously monitored. Cans made of aluminum alloy or tin-coated low-carbon steel are lacquered internally to seal the metal and prevent corrosion from contact with the beverages. Soft drink manufacturers also recommend specific storage conditions to retail to ensure the beverages para hindi ma-spoil. Bale yung sabi dito, yung shelf life ng soft drinks is generally at least 1 year. Kaso may mga umaabot pa ng more than a year na nakatambak sa mga stores. So yun lang po. Next is recycling.
Recycling. The $27 billion US dollar soft drink industry generated about 110 billion containers each year in the nearly 1990s. Environmental concerns continue to lead to improvements and innovations in quality, improvement of fillable and reusable containers. Basically, may tatlong types of materials na ginagamit sa soda packaging. Yun yung aluminum, plastics, yung types of materials na po. Meron pa yung mga subtypes. Yung aluminum,
Sige po. Sige. Ingat po.
na-recycle yun, wala masyadong loss dun sa quality ng material. Then, in terms of plastic naman, meron siyang na ginagamit. Yung PET, HDPE, at saka PVC. Yung PET, also known as polyethylene terephthalate, 7% sa carbonated soft drinks. Then, HDPE naman, so, yun yung thermoplastic na made from petroleum. And then yung PVC, isa din siyang type of thermoplastic pero hindi siya masyadong ginagamit sa packaging kasi sa mga pipes siya ginagamit. Yun siya well-known. Then sa recycling process naman, sa aluminum recycling process, meron ditong binigay na 7 steps. First is yung sorting. Sa sorting, from the word itself, sinusort yung type of material depending on classification. Kung glass ba siya, aluminum, or plastic. Then sa shredding naman, yung aluminum, sinashred siya into small pieces para reduce yung volume niya. Then yung mechanical and chemical processes, yung surface ng aluminum pieces, ini-scrub siya para malinis. Then, ito rin yung preparation for melting. Then, the fourth step is yung melting. Ayan, yung temperature na ginagamit dito is 750 degrees Celsius sa mga high-capacity furnaces. Then, yung removal of byproducts naman to purify the substance na nire-recycle. Then, the creation of aluminum alloy are created by adding like copper, zinc, and magnesium. Then, compounding, ayun na. Gagawa niya ng bagong byproduct gamit yung mga recyclable materials na yun. Yun lang po yung report namin. Thank you. Next slide, please. Ay,
Tapos na
video.
yun yung sabihin.
Sir, may video po na ipi-play.
Soft
Ay, sa soft drinks pala,
are very
soda?
popular drinks.
May video?
Bale, may video po kami, sir. No? Parang summary.
sige.
No?
Okay.
Soft drinks are very popular drinks that are mainly composed of carbonated water, sugar, and flavors. Nearly 200 countries enjoy a sweet effervescent soda with an annual consumption of over 34 billion gallons. Soft drinks are considered the most popular beverage segment in America. Materials used. Carbonated water makes up 94% of soft drinks. Carbon dioxide gives the drink a special tickling and bite, and also acts as a mild preservative. Carbon dioxide is a unique gas suitable for soft drinks because it is inert, non-toxic, relatively inexpensive, and easy to liquefy. The second main ingredient is sugar, which makes up to 7 to 12% of soft drinks. Used in dry or liquid form, sugar adds sweetness and density to drinks and enhances the taste in the mouth, an important component in consumer enjoyment of soft drinks, of course. Sugar also balances the taste and sourness. Sugar-free soft drinks emerged from a sugar shortage during World War II. Soft drink manufacturers turned to high-intensity sweeteners, especially saccharin, which was discontinued in the 1970s when it was identified as a potential carcinogen. Other sugar substitutes were introduced more successfully, most notably aspartame, or NutraSweet, which were widely used in diet soft drinks in the 1980s and 1990s. Because some high-intensity sweeteners do not provide the desired mouthfeel and sweet aftertaste, they're often combined with sugar and other sweeteners and flavorings to enhance the drinks. The overall taste of soft drinks depends on a complex balance of sweet, sour, and sour. Tamarind adds a nutty flavor to the background of tastes and enhances the sensation of quenching thirst by stimulating saliva. The most common acid in soft drinks is citric acid, which tastes like lemon. The acid also lowers the pH, preserving the drink slightly. Other additives in very small quantities improve the taste, mouthfeel, aroma, and appearance. There are many scent options too. They can be natural, identical to nature, or artificial. Emulsions are added to soft drinks primarily to enhance the optical eye by acting as an opacity agent. Saponins increase the foam head of some soft drinks, such as cream soda and ginger ale. Preservatives are added to soft drinks to inhibit the growth of microorganisms and prevent their deterioration. Antioxidants like BHA and ascorbic acid preserve color and taste. In the early 1980s, in response to increasing public health concerns, soft drink manufacturers turned to natural additives. Manufacturing of soft drinks. The production of soft drinks is a multi-step process and involves several steps before reaching the consumer. Most soft drinks go through a similar life cycle, from the syrup producer through the bottling plant to the distributor to the retailer and finally to the final consumer. Each component is as important as the other to ensure CSD is properly manufactured and packaged. Let's look into the details of how the manufacturing of soft drinks starts and reaches you. As it's a soft drink, water becomes the most important ingredient, so workers must pay attention to it. The quality of the water makes for a great drink. Water contains various types of impurities, microbes, organic matter, and airborne particles which can affect the color and taste of the drink. The traditional technical approach is to remove all these impurities, which involves sequential coagulation, filtration, and chlorination of the water. The coagulation process involves mixing into the water a precipitated flaky gelatinous substance. All suspended matter in the water is absorbed by the floc and consequently increases in size. The filter catches it easily. To remove fine shale particles, water is poured through a sand filter. Water is sterilized to remove microbes that can affect the color and taste of the water. Water is collected in a tank and treated with chlorine. After some time, the reaction gets completed. The water is then dechlorinated using an activated carbon filter. This removes all organic residues. Before the water is fed to the dosing station, the water is de-aerated with a vacuum pump. Now it's time to mix the ingredients. Depending on compatibility, the dosing station is filled with aroma concentrates and dissolved sugars in a series of presets. All materials are then transferred to the batch tank. There, these ingredients are carefully mixed under controlled conditions. Movement is kept under control, otherwise it'll cause unwanted ventilation. Flash pasteurization, or UV radiation, is used to sterilize syrup stored in tanks. Some proportions carefully combine the syrup and water, which also regulates the proportions of the liquid. To avoid aeration of the mixture, carbon dioxide is pressurized in the vessel. This process is called carbonation. Carbonation is the process of adding carbon dioxide to a liquid, also known as fizzing. This always happens under very high pressure. When the pressure is reduced, carbon dioxide is released from the drink. This creates bubbles in the liquid. It makes sparkling water. The temperature of the liquid must be kept under controlled conditions too. Today's carbonators are equipped with an automatic cooling system. Now, the drink is made, but it's the packaging that attracts you. Let's see how it's done. Packaging of soft drinks. You must have seen that soft drinks are packaged in glass or plastic bottles, lead-free aluminum or plastic cans. Did you know sales of soft drinks began with the use of ice coolers in the early 20th century? Currently, most beverages are chilled by electric refrigerators for on-site consumption. Vending machines dispense soft drinks in cups, cans, or bottles, and restaurants, bars, and hotels use dispensing guns for high-volume jobs. There are two methods of selling soft drinks by the glass. With the premix system, the finished drink is prepared by the soft drink manufacturer and filled into 5 or 10-gallon stainless steel tanks. The drunk tank is attached to the vending machine where the drink is cooled and dispensed. With a post-mix system, the engine has its supply of water and carbon dioxide. Carbonated water as needed and mixed with flavored syrup when poured into glasses. This is how soft drinks are made. But what about quality control? Quality control. Soft drink manufacturers adhere to strict water quality standards for allowed dissolved solids, alkalinity, chlorides, sulfates, iron, and aluminum. Not only for the benefit of public health, but clean water also facilitates the production process and maintains the consistency of taste, color, and body. Microbiology and other tests are performed regularly. The National Soft Drink Association and other agencies set standards to govern the quality of sugar and other ingredients. When soft drinks are made with low level sugar, the particles in the drink spoil it and form flakes. To prevent spoilage, sugar must be handled with care in a clean, dry environment. Soft drink manufacturers need to check raw ingredients before mixing them with other ingredients, because preservatives may not kill all bacteria. All containers, pumps, and tanks are thoroughly sterilized and continuously monitored. Made of aluminum alloy or tin-plated low-carbon steel, the cans are painted internally to seal the metal and prevent corrosion when in contact with the drink. Regular consumption of soft drinks can be harmful. We saw how soft drinks are made, but it's important for you to know there is proof that soft drinks can harm your bodies. Yes, it's true. Regular consumption of soft drinks has been linked to various chronic health conditions. This increased risk is largely due to the added ingredients in soft drinks, especially sugar. Some sugar-sweetened soft drinks contain 40 grams or more of sugar per 12-ounce serving, which exceeds the daily recommended sugar intake for adults. Consuming just 1 to 2 servings of sugar-sweetened soft drinks per day significantly increases the risk of metabolic syndrome and type 2 diabetes. In addition, both men and women who drink sugar-sweetened beverages have an increased risk of coronary heart disease, preterm birth, and death. Click on one of the 2 videos on your screen right now. We'll catch you guys in the next one.
Mistake ka na 9, hindi.
Oh, baka before 9. Ako na doon sa ano. Sa gilid, hindi ko alam. Wala akong susi. Okay. Doon na ako doon sa ano.
Okay na to? Okay na?
Okay na
Class?
po, sir.
Sige. So, pakipasa na lang yung yung PPT class, no? So, anong gagawin natin? Pwede na, mag-leave na? Pwede na mag-leave kayo? Palagay nyo.
Yes, sir.
Kasi
Yes,
hindi
sir.
naman